There is grandeur in this view of life.
Welcome to Evolution Talk with Rick Coast, an introduction to the oldest story ever told.
There's a very subtle dance going on around us. It's constant, and without it, well, there'd be nothing at all. Fortunately for us, and for everything else, this dance is attached to a never-ending story. The story began with a bang. The one that started it all. And how it will end, well, no one can say. But until it does, the dance continues. Driving the beat are these little things called alleles. The name of the song they play is microevolution. And we've talked about alleles before, but to revisit what an allele is, we have to go back to genes. Genes are lengths of DNA that contain the code or the instruction manual needed to build our bodies, right down to the traits exhibited by that body or our body. Things like hair color and foot size. I have brown hair and blue eyes, brown hair that might be slowly going gray, but at least it's still brown. My brown hair is tied to a gene. Now, there are different versions of the gene for hair color. You might have blonde hair or red hair. The different versions of the gene are called alleles. I have the hair color allele that codes for brown hair. Put simply, an allele is a different version of the same gene. We'll get to a great example of this in just a few minutes. So, alleles drive the beat of the song called microevolution. But what is microevolution? I have a simple answer for that too. It's the opposite of macroevolution. I know, I just cheated. But we'll tackle what macroevolution is in the next episode. Microevolution is really just what it sounds like. It's small steps or small-scale genetic changes in a population. Now let's bring alleles and microevolution together. During sexual reproduction, an organism inherits half of its genetic material from each parent, and the resulting organism is a unique combination of genetic material. Say, a cat that has an allele for black hair mates with a cat that has the allele for orange hair. It's possible the result could be a kitten with black and orange patches. The genetic reshuffling of traits increases the genetic diversity in a population. Now, it doesn't mean that mixing traits will result in them expressing in unique patterns like the kitten with the black and orange patches. It could have been a black kitten or an orange kitten as well. You never know what you'll get when you shuffle the deck. New alleles can appear, and they do appear, all the time. They can happen through a mutation in the gene. The brown hair allele might have been the only version carried by Homo sapiens at, say, one time in the far distant past, but a mutation in that gene may have occurred, which resulted in an allele that expressed itself in the hair of an individual where instead of brown, it was blonde. Alleles also flow from population to population. This is called gene flow, and I think we've touched upon that before. Let's say one population of people have only brown hair, and they come into contact with a group of people that are a mix of brown and blonde hair. Well, things happen behind closed doors, and the group that once only had brown hair begins to have some babies with blonde hair. The blonde hair allele mutation, never before present in that population before, is now part of their future generation's genetic code. It's really kind of amazing stuff. Now, back to our dance. I said I had a great example of alleles and microevolution, and it's a classic one, and you might have heard this one before. It involves the peppered moth. It not only involves alleles in the song called microevolution, it also reveals the composer of the song, natural selection. The story goes that before the days of the Industrial Revolution in England, there lived a population of peppered moths that had light-colored wings with dark spots, and they loved to cling to lichen-colored trees that matched their coloration. And their coloration served as a sort of, call it a camouflage to protect against predators. And one day, a mutation occurred. And that mutation altered the gene that expressed itself with light-colored wings. Now there were two versions of the gene, or two alleles for wing color. The moths with the new allele, the one that was the result of the mutation, had darker colored wings. And this, unfortunately, made them easier to spot by predators. When the dinner bell rang, they were the main course. The peppered moth population was quite large, and it liked to reproduce, which it did so often. So the two alleles continued to exist. There were understandably more of the light-colored moths than the dark ones, because the dark ones were the ones easily seen by predators who loved the taste of moth. With the arrival of the Industrial Revolution and its proliferation of factories, those factories produced a lot of smoke and soot from coal burning. The soot settled over the surrounding landscape. The trees that were once lighter and covered with lichen were now smudged with soot, and the lichen died out. Now, who do you think benefited from the darker trees? Well, that's right. When the dinner bell rang, it was now the moths with the allele that gave them light-colored wings who were at risk. Those with the dark-colored wings had much greater survival rate, and their population flourished. Remember, microevolution is small-scale genetic changes in a population. The introduction of the allele for darker wings gave natural selection something to work with. We see microevolution in action today with antibiotic resistance in bacteria. Bacteria reproduce rapidly, and because of this, mutations are more frequent. They happen all the time. Some of the mutations provide a stronger resistance to certain antibiotics. Where an antibiotic once worked to decrease the spread of the bacteria, it was now not as effective because of the mutation. All it took was a small change in their genetic material. In this case, it was the mutation that provided the benefit of resistance to the antibiotic. Those with the resistance survived, and their population grew. That's why new antibiotics are manufactured all the time. It's a constant battle. And because bacteria reproduces at incredible rates, and new mutations happen all the time, new antibiotics to combat the new strains can't be made fast enough. The bacteria are winning. They have another advantage too, and it's almost an unfair one as far as battles go. Not only do they pass on the resistance genes to their offspring, but they can also pass it on to other bacteria species through certain processes that only bacterium enjoy. They can practically pass off and share genetic code like we do trading cards. Yeah, I know, it's scary. Let's end their little dance right here and return to where we were at the beginning of the episode. So, the dance of the alleles continues. With it, we see new dance moves that didn't exist, all based on the same beat. The song goes on, just like life.
The genes, the set of instructions inside us, don't rest. Just as they have come from our ancestors before us, so too do they march on into our children and their children's children.
This is Professor Richard Dawkins.
Our genes are a kind of archive of the remote past, and they go through us to the remote future. Henry Dawkins may be my great-grandfather, and he's put some genes in here. But my 200 million great-grandfather was a fish. And by the way, the same fish was your 200 million great-grandfather too. Amazingly, even he has put some genes in here. And they too have a chance of going on to the remote future.
I hope you enjoyed today's episode of Evolution Talk. I'm Rick Coast, and if you find value in this show, please consider supporting it at evolutiontalk.com. I'd love to keep the show alive and without ads, and I can only do so with your assistance, so help spread the word. Share the show with your friends. And at evolutiontalk.com, you'll find more information, recommended books, and also ways to contact me. I'd love to hear from you. And I hope your week is going well, and until next time, please take care of yourself.
Evolution Talk is a Rick Coast production.